So here's the original MPU that was sent in that unfortunately is covered in alkaline, and it's just not economical to do the repair just due to reliability long term. So we're going to go ahead and build a new board from Victor, aka Dumbass, on Pennside. Here on the bench we've got a WPC 89 driver board, as well as the Victor, aka Dumbass, reproduction 89 CPU that I have built here. So I've got this populated with NVRAM, as well as the customer's ASIC and the customer's 6809. Other than that, everything here is brand new. And the driver board here, so what we did is we replaced C5, C4, and C2. So C5 has been replaced, C4, as well as C2, and I've got that sitting up here a little bit higher off the board just so you can see if there is any leakage that happens there with that, which is fairly common on these boards, but we should be good to go for quite a few years. I'd say around 30-40 years before we'd have to worry about anything like that, hopefully. Anyways, we've got a total of 7.156 headers here on the board. So one being the power out here to the MPU, as well as the 2 GI over here, the 2 AC input, the ground, and then also the 12 volt power header there. And then we've got a TIP 107. So here column 2 was actually locked on, which ended up being a faulty TIP 107, so that's been swapped out. And we've got a 1N5401 blocking diode just installed here, and Chris covers that in all of his videos, and that's actually who I've got that from, as well as the 4.27 volt watchdog that I've added here to the new MPU. But let's go ahead and get this thing booted up, and I've got the test ROM installed here on the board. That way we can go ahead and fully test the MPU there. Let's get our test report, time and date not set, and go ahead and get into, oh, sorry, wrong button. Get into test, and first test is going to be switch edges. So we're just going through, testing both rows and columns, just moving diagonally through the circuit. And we'll go ahead and capture the coin door buttons here. And all of the switches are working correctly. And solenoid test. So just going through and testing the solenoid circuits here on the driver board. Test the general illumination. So these 4 will illuminate by themselves, and the last 2 here together. And that circuit is functioning correctly. We don't have a soundboard, so we won't worry about that part of it. But we will test both lamps and flashers together. And those are working. And that is actually my display board, so no sense in testing that there. I did want to point out, however, the 0.156 header here for the GI input had already been swapped. It's kind of ugly. It's, not the best looking there, but in the sense that it is working, there's no sense in adding more heat to that because it's not going to do anything but make it appear better, hopefully. More often than not, adding more heat to something like that is just going to make it worse. So we're just going to leave that alone. But other than that, we are 100% here on this driver board. And I've got another WPC MPU that we will go ahead and test as well. Here is the Doctor Who MPU. And I've already got this set up. So basically what we've done with this MPU here is we've replaced the power input, so the 0.156 header here. We've also replaced the 100 volt input capacitor, and the we swapped out the watchdog for a 4.27 volt watchdog, as well as added a socket and installed NVRAM here to the board. So let's go ahead and run this through its test. And first test we're going to do is switch test. So again, just running through diagonally, testing both rows and columns. And then we'll test the coin door switches. And let's see, solenoid test. Good to run. There's all the solenoids and general illumination. And we're just essentially just testing that the MPU is interfacing with the driver board here. Alright. And then lamps and flashers. There we are. So that concludes everything here for Doctor Who. And so I will go ahead and get these packaged up and get these sent back to you. So thank you so much.